Warm greetings from Rohini College of Engineering and Technology. I am Professor Radhika from Chemistry Department. In this video lecture series, we discuss about the terms involved in the phase rule. After the completion of this topic, the students can able to explain the definitions and terms involved in a phase diagram. So we know that all chemical reactions can be classified into two types. One is irreversible reactions and reversible reactions. The homogeneous reversible reactions can be studied by using law of mass action, but heterogeneous systems require some different methods. The phase rule, which is given by Willett Gibbs, is mainly used to study the behavior of heterogeneous reversible reactions. So now you clear that why we study phase rule. In order to study the behavior of heterogeneous reversible reactions, we need phase rule. That phase rule is given by Willett Gibbs in the year of 1874. See what is meant by phase rule. So we know that the equilibrium exists between number of phases. Suppose if the equilibrium exists between any number of phases is not influenced by gravity or electrical or magnetic forces. We know that it is mainly influenced by pressure, temperature and concentration. Then the degree of freedom of the system is related to number of components and number of phases by the following phase rule equation, that is F is equal to C minus P plus 2. That is the phase rule. What indicates means if the equilibrium exists between the number of phases is only influenced by temperature, pressure and concentration, not by gravity, electrical or any other forces involved in it. Therefore, the phase rule is equal to F is equal to C minus P plus 2. Now we discuss about the terms involved in the phase rule. Before that, discuss about what is the uses of or merits of phase rule. So phase rules are applicable to both physical and chemical equilibria. It's a convenient method of classifying the equilibrium states in terms of phases, components and degree of freedom. It helps to decide whether the given number of substances remain in an equilibrium condition or not. Similarly, let us see the limitations of phase rule. Phase rules can be applied only for the systems exist in an equilibrium alone. Only three variables like pressure, temperature and concentrations only consider, not for electrical, magnetic and gravitational forces. See what is meant by phase. Phase is defined as any homogeneous, physically distinct and mechanically separable portion of the system which is separated from other parts of a system by a suitable definite boundary. Let us consider let us take one beaker. Inside the beaker take 5 grams of sand, then add 1 cup of water. So this system containing two phases, one is solid phase and another one is a liquid phase. Each phase has a separate boundary layer. Each phase can be easily separated from one another. So this is an best example of phase. Okay, so it is a physically distinct and mechanically separable portion of the system which is separated from other parts of the system by a definite boundary is called as a phase. So the best example is water system. So water can exist in three phases, either water, ice or gaseous state. So we know that gaseous phase, all gases are completely miscible and there is no boundary between one gas into the another. Let us take air. Air is a mixture of oxygen, hydrogen, nitrogen, carbon dioxide, water vapor, etc., which constitute in a single phase. Similarly, liquid phase. The number of liquid phase in a system depends upon the number of liquids present and their solubilities, that is miscibility. If two liquids are immiscible in nature, it forms three separate gases, separate phases, two liquid phase and one vapor phase. Let us take the benzene water system. Okay, both are exist in a liquid phase but after some time it undergo evaporation, so one gaseous state also exists. So it consists of one gaseous liquid phase, water liquid phase, and another one is a vapor phase. Similarly, if two liquids are completely miscible in nature, it forms only one liquid phase and one vapor phase. Example, alcohol in water. So alcohol completely dissolved in water, therefore it produces only one liquid phase. Similarly, it also produces one vapor phase also. Let us see component. Component is nothing but the smallest number of independent variable constituents by means of which the composition of each phase can be expressed in terms of chemical equation. Let us consider the water system. Water exists in three phases: ice equilibrium with water, water equilibrium with vapor. Therefore, the chemical composition of all the three phases in water is 1. Even though water can exist in three different phases, the main component present in all phases is water alone. Therefore, the component is 1 for this system. Similarly, let us take the sulfur system. Sulfur exists in four phases, namely rhombic, monoclinic, liquid, and vapor. Even though it exists in four different phases, the chemical composition is only 1, that is sulfur. Therefore, the component of the system is only 1. The next one is degree of freedom. Degree of freedom is defined as the minimum number of independent variable factors such as temperature, pressure, and concentration, which must be fixed to define the system completely. So in order to define the system, we need the parameters like temperature, pressure, and concentration. So this minimum number of independent variable factors which helps to define the system is called as a degree of freedom. So if the degree of freedom f value is equal to 1 means it is called as a univariant, 2 means it is known as a bivariant, 3 means it is called as a trivariant. If it is 0, it is called as a zero variant. So in this video lecture, we discuss about what is meant by phase, what is why we are using phase rule, what are the terms involved in the phase rule like phase, component, and degree of freedom. Thank you for listening.